Hey Global Village, what's up? Okay, let me just start out by saying that my primary reason for creating this channel and uploading videos to it is that I don't see myself as a traditional creator in any definition of the word. I mean, it is not my goal to ever monetize my content, nor do I have any real expectation that I'm going to achieve any significant viewership. Certainly not anytime soon, perhaps not even in my own lifetime. I have a perhaps more abstract hope that maybe someone might watch these videos at a point in time and that for reasons completely known only to them, they find what I have to say and talk about to be mildly interesting. But I guess in a certain sense, I'm doing this because it's quite self-serving from the point of view that I'm just doing what people do, and that is expressing my views, opinions, and inspirations, and I guess pain and suffering, and then just putting it out there into the void. And so that leads me to what I want to talk about today, which is my very sincere passion and love for science. And I guess I want to share it because I have a kind of hope that maybe if you're watching this and perhaps you don't have any particular interest in science, perhaps I can convince you that that maybe you can have a passion for it, and that maybe it's there's a hidden potential there to learn and discover the joy of learning and expanding your mind about how the mechanics of the universe works, and that you might end up seeing it as an exciting adventure, that it inspires curiosity. So I guess I would like to start by talking about a YouTube video I watched quite a long time ago, and it led me to asking a very ignorant question. And I could have been mocked mercilessly by other people who understood a lot more than me, but that isn't what happened. I received a response to my question, and it was very kind and extremely informative. So I was watching, I guess it was a science video, which at the time was quite novel, and I hadn't really associated science outreach with YouTube. But nonetheless, I somehow stumbled across this particular video, and it led to a question that I've always had, which, as I said, sort of really exposed my ignorance to the subject. So what I understood enough to know that the speed of light was constant, and that it was the same to all observers, and furthermore, it nothing could exceed the speed of light. So my question was pretty much as follows: if you had a theoretical rocket ship that was traveling at 80% the speed of light in a specific direction, and then you had another rocket ship traveling at the speed at 80% the speed of light in the opposing direction, then relative to each rocket ship, the speed of the other ship should be 160% the speed of light, which of course would appear to break the rules of relativity. And if you wonder how you come to that equation, well, that's simply called Newtonian mathematics. It's simple using addition and subtraction to calculate relative speeds of two objects. And in the case of two objects traveling in the opposite direction, then the rule is additive. So you add the two velocities to get the sum velocity relative to each other. So the actual answer I got was something along the lines of, hey, that's a great question. So I know it would seem that it should be that way, but in fact, the actual relative speed is about 87% the speed of light. It was I can't remember the exact value he gave me, but it was something along those lines. And then he actually went ahead and kind of wrote down or explained all the underlying mathematics that actually resulted in that figure, which was quite baffling, but it also really it sort of cracked open sort of a burning curiosity that I just wanted to understand why it worked like that. And the answer to that question can be found in Einstein's special relativity. And just to clarify, special relativity preceded general relativity, which then included and factored in mass and gravity. Something that I didn't know at the time. I just knew there was relativity, but I didn't even really understand the difference between those two theories. So anyway, I thought it would be a little bit fun to just kind of talk about a hypothetical, so we can just sort of then realize how weird the stated observations about light are, and then what that actually means to our underlying reality. So I thought I'd use a hypothetical that goes something like this. So we've got Usain Bolt, who's recorded at being able to run a staggering 44 kilometers an hour for the 100-meter dash. And we also have the fastest recorded thrown baseball, which is 160 kilometers per hour. So let's imagine we've got Usain Bolt and a baseball thrower at the starting line of a 100-meter dash. Then Usain Bolt takes off and he's flying along at 44 kilometers an hour. Then the baseball is thrown in the same direction as Usain Bolt at 160 kilometers per hour. Now, from the reference frame of the person that threw the baseball, that is traveling at 160 kilometers per hour. Now, as that baseball passes Usain Bolt, who is traveling in the same direction as the baseball at 44 kilometers an hour, then the equation is to subtract these two speeds, and we get 116 kilometers an hour. So again, from Usain Bolt's perspective, that ball is traveling at 116 kilometers per hour. So very simple Newtonian additive and subtractive mathematics to figure out the net speed. Right, so let's do that experiment again, but this time, instead of throwing a baseball, this time he's holding a torch. And Usain Bolt takes off 44 kilometers an hour, and the torch is then turned on, which results in electromagnetic waves that fall into the visible light spectrum, traveling in the same direction. And the speed of these electromagnetic waves is approximately 300,000 kilometers per hour, just under. And this is from the observation of the person holding the torch. So as the light passes Usain Bolt, you would think the correct answer would be 300,000 kilometers an hour, just under, subtracting 44 kilometers per hour. But in fact, that is not the answer. The answer is that it is, from Usain Bolt's perspective, it is 300,000 kilometers per hour, or just under. In other words, exactly the same speed as that being observed by the person who is using the torch. So we have to ask ourselves, how on earth does that make any sense? And interestingly enough, the answer is that in fact it is because space contracts and time dilates. And if we just make that a little bit more specific, let's go back and talk about when we were doing the baseball comparison, because we just used simple subtraction to calculate the value. Now, as it turns out, that value is almost right, but not quite. There's an infinitesimal error in that calculation, because in fact, to get the perfect answer, you would actually have to use the mathematics that was devised by Einstein rather than just simple Newtonian. Now, the point being, because that value, that error margin, is so tiny that it just doesn't matter. In fact, for example, if it was a speeding bullet that was shot from a high-powered rifle, it still would not matter. You have to be traveling at you have to be traveling quite close to the speed of light before the value becomes significant and noticeable. So in the case of the torch, indeed that is as fast as you can go, and at that point the error margin is very noticeable if you were to use simple Newtonian mathematics, and in that case you really have to use Einstein's mathematics if you want to get the correct answer. And again, to get that correct answer, the mathematics has to take into account the fact that because Usain Bolt is traveling at 44 kilometers an hour, he is causing the space-time fabric to warp ever so slightly. He's causing space to contract and he's causing time to dilate. And because of those two things, when that light travels past him, from his observation, that light still appears to be traveling at 300,000 kilometers per hour, or just a tiny bit under. So isn't that unusual, right? That we live in a universe where space-time can be treated as a malleable fabric that is not consistent. And something else you may have, you'll just notice I referred to space and time as space-time. And the reason I did that is because there is a relationship between the contraction of space and the dilation of time. So they are mathematically related in the way they behave. So in that sense, they are united and uniform in inextricably linked by an equation and mathematics. So hence space-time rather than just space and time. So for example, in Newtonian, the Newtonian view of space and time is that space and time are two completely separate and independent metrics, and one does not affect the other. So anyway, if that at all creates a little bit of curiosity and you think, well, that's kind of odd, I want to proselytize a couple of potential videos that I think are incredibly well worth watching, because I certainly watched them and I learnt so much. And in fact, it was probably my curiosity about special and then general relativity that sort of sent me down the science rabbit hole, and I've never been able to escape it since, nor would I want to. So the videos I'm talking about are by Brian Greene, and he very kindly uploaded these videos to the World Science Festival channel, and they are either a 2.5 hour slightly abridged version of the theory of special relativity, and then an 11-hour version which includes all the related mathematics. Now, I don't think you have to watch the math version to really understand the underlying principles. You can quite happily watch the 2.5 hour version. But having said that, I can tell you that the 11-hour version, if you're willing to just slowly work your way through it, maybe an hour at a time or whatever, the underlying mathematics is surprisingly easy. It's really not much more than algebra. And I would credit most people with being able to handle that level of mathematics. And it's very well explained with lots of graphs, lots of computer animations. It is a incredibly well put together tutorial, and it is just an incredible service to humanity that he uploaded these videos and have made them free for anyone to watch, and that all it will cost you is your time. As I said, if you can have your curiosity tapped and you just start to want to understand more, what happens is for every answer you acquire, more questions will start to pop up, and you'll just find yourself on this endless quest of trying to learn more, and you'll find yourself asking questions about why does this work, or how come it works that way, and it is just a never-ending adventure. So yeah, I hope I can inspire other people to take that journey. And I guess my underlying agenda to that as well is the fact that in this day and age, certainly at the time that I'm creating this video, there seems to be somewhat of a war against science, and there is powerful anti-science sentiment all around the world. Science itself has become heavily politicized, and unfortunately science is a victim of that. The problem, though, is that I personally feel that there are two significant qualities about being human which I find to be incredibly beautiful and inspirational. One of them is that our ability to empathize and show love and compassion to others. The other is our ability to harness, explore, and pursue the scientific method, our desire to learn how things work, to understand the basic mechanics of the universe. That this to me is one of the things that makes humanity very special, and something that I hope has a bright future rather than a dark and disappointing one. Anyway, I will include links to these two videos in the description, and please just consider taking a bit of an adventure down the scientific rabbit hole. I think it will be an expression and an exploration of a part of your humanity that you may not have up to this point ever seriously considered exploring. Anyway, that's all I got. Bendy out.